Assalamu alaikum, this is Shakir Ahmed. In this tutorial, we will learn about logistic regression. First, I would like to tell you what is logistic regression and why we use a logistic regression. Basically, when we have a continuous dependent variable and continuous or categorical independent variables, we use a linear regression model and we assume that the responses are linearly dependent on some uh, determinants or regressors. But in certain cases, we have binary or classification of a category in our dependent variable. For example, in most of the medical studies, we are often interested in having a disease or not having disease, and we use different causes of the disease as our independent variables and see the effect of different causes on the outcome, disease outcome. So we basically divide the response into categories. Either the patient is recovered or still ill, or he is died or alive. So in such cases, we use logistic regression. Logistic regression basically uh, use a generalized is a form of generalized linear model where we regress the logit of probabilities or the log of the odd ratios as the dependent variable on some regressors. So let's start with the uh, heart failure dataset in our example, and we load the package deployer first and the library ktools and rocr. These three packages are required in addition to the packages we already installed. So we need these three packages for logistic regression, and we import our dataset in CSV format, health failure clinical records dataset, and we have some variables as these. Here we use whether the patient has anemia or not as our dependent variable, which is a binary variable, 0 and 1. 1 for having anemia and 0 for not having anemia. If you want to see the variable in detail, you can just write str.dat to see the structure of your dataset and run. You will see the dataset is numeric or integers and other formats. So we have the death event as integers and the anemia status is also in integer form. So we may use the death status or smoking or sex or anemia as the dependent variable. So for simplicity, I would like to use anemia as our dependent variable, and I would just like to split the data set into test and training. Basically, we need to see the predictive ability of our power, our model for some unknown data points. That's why we separate the data set into training part and the test part. We just run the model for the training part and check the validity or accuracy of the model using the test set. So the split command is given as sample.split and your data set, and the split ratio is 0.8. Basically, I am keeping 80% data in my test set and 20% data in my training set. So just run the command, and the split is true for training set and the split is false for the test set. So I have two sub data sets as training regression and test regression. And I would just like to run the generalized linear model as the family binomial because the dependent variable is binary, so I would like to use the GLM as binomial. If I have count values, then I would like to use Poisson and negative binomial and other forms of generalized linear model. So we have the dependent variable anemia and the two independent variables creatinine phosphokinase and serum sodium, and the data set is training data set. So just run this model 1, and see you will see the model 1 as by printing model 1. uh, Here are the intercept and the two regression coefficients, and this is the total degree of freedom, and the uh, residual null deviance is this and residual deviance is this. The null deviance basically tells us the error when we use only intercept, and the residual deviance is obtained when we have regressors in the model. And the Kaik information criteria is tells also the predictive ability of the model. The smaller value of Kaik information criteria indicates better model performance. And you can also run the model performance as the summary model. You will see uh, the testing for the intercept alone and the two coefficients, and these are the standard error corresponding to these estimates, and these are the z values, and these are the uh, p values. So we see that the creatinine phosphokinase is significant for the logit of or the log of the odd ratios, and we can see the log of odd ratio decrease while increasing the creatinine phosphokinase. A higher creatinine phosphokinase yield a lower value of log of odds. It means when a patient has higher creatinine phosphokinase, he has lower chance of having anemia. This is the basic interpretation of the model you need to make while writing your report of the logistic regression. So hope you will understand. And these are the significant quotes, and the null and residual deviance and Kaik information criteria are already explained. Uh, you can see a summary statistics, 5 number summary statistics for residual deviance here, the minimum value of the residual and the maximum value of the residual and the median and quartiles. So now we just want to see how the model predicts the unknown case, or the test set. For example, if we want to see if a respondent has a value of creatinine phosphokinase uh, a specific amount and the serum sodium a specific amount, then what will be the log of the odd ratio for that respondent, or the probability of having anemia for that respondent. So you can just predict the probability here. These are the probabilities for the unknown cases or the test sets, and you can convert these probabilities to the values. If the probability of having anemia is greater than zero point 0.5, then we will classify that patient to the anemia class, and otherwise to the non-anemia class. So just run this code and you will see the probabilities, the values of the uh, test set for which case has the anemia and which case don't doesn't has have the uh, anemia. So uh, let's see the confusion matrix, which provides the classification and the actual class of the respondent. And you can see the missing class uh, ratio as missing class R there, and the accuracy is 0 for this model, and the receiver operating characteristic curve is obtained as the proportion of the values correctly classified, and you can also find the area under the curve using the performance and the receiver operating characteristic predicted values, and measure as area under the curve, and you can just find the area under the curve, which is 58%. A higher value of area under the curve tells the higher performance of the model, and you can plot the receiver operating characteristic curve in term of percentage, and you will see a plot ROC curve here, and more the value of the uh, area under the ROC curve tells more accurate, the model is more accurate, and the model performance is good in predicting the probabilities. And similarly, the area under the curve can also be seen using the AUC curve, and this tells the value of area under the curve, and the higher value of area under the curve tells that the model performs well. So this is all about the logistic regression, which is a machine learning technique of classifying the new training points, new test points, when by training the data on a given sample, and we can classify the new cases as having disease or not having disease according to the observed characteristics of the patient. So hopefully you have enjoyed the video and learned something new. If you have any comment or any confusion related to this tutorial, you can write in comment section. Thank you.